CSET insight question, vectors, number 1A. So looking at this question, at first glance, it seems like we're trying to figure out the cosine of the angle between A and B. Well, we need to remember this invaluable formula, which is a flashcard idea. And it is that A dot B is the magnitude of A times the magnitude of B times cosine of theta. You need to remember that form. So what we see is we really need to solve for the value of A dot B. We need to solve for mag A and for mag B. So these are really the three questions that we need to answer in order to solve this cumulative concept. Well, off to the side, let's go ahead and address our first concept, A dot B. Let me go ahead and use my flashcard color. Whenever we take the dot product of any two vectors, let's just call them u and v. And they're in the form x, y, and then our second y pair, x, y pair. So here we have our two vectors. When we do u dot v, we just multiply the two x components together, so x1 times x2, plus we add the two y components. Applying this specifically to our question now, what we see is that A dot B equals 2 times 2 plus negative 1 times 1 plus negative 2 times 3. If you're paying any attention, you'll notice that I wrote the dot product's definition out with two variables. If we have a third dimension, it's easy enough to add that. And we would just complete the idea by multiplying our z's together and adding them. Now, we calculate this number, 4 minus 2 minus 6, so negative 4. So A dot B is negative 4. That's the first part. For the second and third parts, and there's really no reason that I chose to do this before these other two. It's not like I had to do this and then do these two things. I'm just going left to right. Anytime we're talking about magnitude, what we're talking about is the length of a hypotenuse. Length of a hypotenuse is much easier to visualize in 2 dimensions and gets harder in 3 dimensions. But whenever we're talking about the length of a hypotenuse, we're always talking about Pythagorean theorem. So, it should be no small surprise then if we have a vector, let's again use just u, and that was x1, y1, z1. If we wish to find the magnitude of u, all we do is take the square root of the x coordinate squared plus the y coordinate squared plus the z coordinate squared, all of that under the root. So another flashcard concept for our magnitude and also for our dot product. So applying this to the question now, we simply have to plug in our 2, negative 1, and negative 2 values. So the magnitude of A is simply root 2 squared plus negative 1 squared plus negative 2 squared. Simplify this down to 3. Go ahead and find the magnitude of B now. I'll pause for a couple seconds. So for the magnitude of B, what you wanted to get was root 2 squared plus 1 squared plus 3 squared, or root 14. Now, we have our three parts that we were originally seeking. So, if I'd left a little bit more space, I'd get to write it here, as is. I'm going to finalize our thought down here. And what we have is the idea that A cross B over mag A, mag B equals the cosine. A dot B we know is -4, mag A is 3, and mag B is √14. Let's go ahead and get the root out of the bottom. Which then simplifies a little bit further. We can divide out 2 and we get -2 √14 over 21 is our answer. Looking back, this was the first concept that came to mind, our flashcard idea. And there are, really, if you look at it, 4 operating parts in there. There's the dot, there's mag A, there's mag B, and then there's the cosine. Since the cosine was the unknown, we had to know the other 3 parts. So we just went step by step and laid them out, using a couple of flashcard ideas along the way. So, 3 flashcard ideas here. Very similar to a question type. It pops up on your CSET.